Welcome to Programming Fluency. This is section 3.5, Input Validation Patterns. Until now, your programs used values baked right into the code. In this video, you learn how to read input from the user, check that it is valid, and ask again when it is not. Let's begin. Every program you have written so far uses values baked into the source code. Real programs read from the user while they run, and users make mistakes. So let's turn to reading input and checking that it is good. Here is the plan for this video. First, we look at why we validate input. Real programs read values from users, and users make mistakes. Next, you learn to read input with scanf. You will see the ampersand rule and how to read several values at once. Then we check the return value that scanf gives back. It tells you whether the read actually succeeded. After that, you build an input loop. Using do while, your program keeps asking until the user gives a valid value. Finally, you meet the ternary operator, a compact one-line way to choose between two values. Why do we validate input? Every program so far uses hard-coded data, values baked into the source code. To change the input, you edit the code and compile again. Real programs do not work that way. They read data from the user while they run, numbers, menu choices, file names. And users make mistakes. They type letters when you expect digits, or they press enter without typing anything. Your program has to handle all of it gracefully. The printf function sends text to the screen. The scanf function does the reverse. It reads input from the user and stores it in a variable. Here is the definition. Scanf is a standard library function that reads formatted input from the keyboard. It takes a format string describing what to expect and the address of a variable where the value should be stored. The ensign gives scanf that address. Here is the simplest use, reading one integer. We declare an int called age. We print a prompt. Then scanf, with the format %d and the address of age, reads a decimal integer from the keyboard and stores it in age. Finally, we print it back. The %d tells scanf to expect a decimal integer. The age is the address of age. It tells scanf where to store the value it reads. Why does scanf need the ensign when printf does not? Because printf only needs to read the variable's value. Passing the value itself is enough. But scanf needs to change the variable. To change it, scanf must know where the variable lives. That is its address in memory, and the in operator provides it. For now, just remember the rule. For the scalar types here, int, double, and char, every scanf target gets them ensign in front. Strings are the exception, but those come later. Without the ensign, scanf does not know where to put the result, and your program may crash or corrupt memory. You can read several values in one call. Here we declare width and height. We prompt, then scanf, with the format %d space %d and the addresses of width and height, reads two integers. If the user types 8 space 5, the program prints area equals 40. The format string %d space %d tells scanf to read two integers separated by whitespace. The user can use spaces, tabs, or even press enter between them. Scanf treats all whitespace the same. Here is what most beginners do not know. Scanf returns a value. That return value tells you how many items were read successfully. Here is the definition. The scanf return value is the number of items successfully read and assigned. Scanf %d and n returns 1 on success. If the user types something that is not a number, scanf returns 0. If input has ended, it returns a special constant named EOF, which is typically -1. The return value is your main tool for detecting bad input. We save it in a variable called result. If result equals 1, scanf read the number, so we print it. Otherwise, we tell the user it is not a valid number. Type 42 and result is 1. Type hello and result is 0, and n is left unchanged, holding whatever garbage it had before. Always check the return value. Ignoring it means your program silently uses garbage when the input is invalid. This is one of the most common bugs in beginner C programs. Now combine the return value with a do-while loop. The idea is simple. Ask for input, check it, and ask again if it is invalid. This is the classic use for do-while because you need to ask at least once before you can check the answer. We save scanf's return value in R if R equals EOF. The input has ended, so we break out of the loop instead of asking forever. Otherwise, the while condition combines two checks with the logical or the first check. Is R not equal to 1? That means scanf failed to read an integer. The second check. Is age less than 1 or age greater than 150? That means the value is out of range. If either check is true, the loop repeats. It exits only when scanf reads an integer and that integer is in range. This figure shows the two-stage validation. The prompt and the read happen first. Then the condition checks two things. First, did scanf succeed? Did it actually read a number? If not, loop back and prompt again. Then, is the number in range? Does it make sense? If not, loop back and prompt again. Only when both checks pass does the loop exit and the value get used. There is a problem with non-numeric input. When the user types a BC, scanf fails and returns 0, but it does not consume the bad input. The text of BC stays in the input buffer. On the next iteration, scanf reads a BC again, fails again, and the loop spins forever without ever showing a new prompt. The fix is to clear the buffer. The getChar function reads one character at a time. We save each character in C, and the loop reads and discards characters until it hits the new line, the enter key. We also stop if getChar returns EOF, so the loop does not hang when the input ends in the middle of a line. That clears whatever junk the user typed. Notice the semicolon right after the parentheses. That semicolon is the entire loop body. It is an empty statement. All the work happens in the condition. This is not a typo, and it is different from the trailing semicolon on a do-while loop. Here is the standard input validation pattern. In C we save the return value invalid. If valid equals EOF, the input has ended, so we break out. Otherwise, if valid is not 1, we clear the bad characters from the buffer before looping, stopping at new line or end of input. Let's read it step by step. First, prompt the user. Then call scanf and save its return value. On end of input, stop. Otherwise, if scanf failed, clear the input buffer. And repeat until scanf succeeds and the value passes the range checks. This pattern turns a fragile demo into a program someone can actually use. Let's meet the ternary operator. The ternary operator, written ? Is a conditional expression that gives one of two values. The syntax is condition, ? Value if true, value if false. It is the only C operator that takes 3 operands. That is why it is called ternary. Here is how it reads in English. Is A greater than B? If yes, the result is A. If no, the result is B. The ternary operator is a compact if-else that produces a value. Compare the two. On the left, using if-else takes 5 lines. We declare max, then an if-else assigns either O or B on the right, using the ternary takes 1 line. Int max equals open paren, a greater than B, close paren, question mark, a colon B. Both do the same thing. If O is greater than B, max gets A, otherwise max gets B. The difference is that the ternary is an expression. It produces a value you can assign directly. This figure shows the branching. The decision, a greater than B, leads on true to result equals A, and on false to result equals B. Like if else, exactly one branch runs, never both. If the condition is true, the result is A. If it is false, the result is B. The side that is not selected is never evaluated. This matters when a branch does real work, because only the chosen one actually runs. The ternary operator works anywhere an expression is expected, including inside printf. Here score is 82. We print result %s and then the ternary. Score greater than or equal to 60, question mark, pass, colon, fail. The output is result pass. The %s specifier prints a string. The ternary gives either pass or fail depending on the score. Writing this with if-else would need 2 separate printf calls or a temporary variable. The ternary keeps it to 1 clean line. When should you use the ternary operator? Use it for simple two-way choices that fit on 1 line, picking the larger of 2 values, choosing between 2 strings, computing a conditional value. Do not use it for anything complex. Nested ternary operators are legal but hard to read. If the logic needs more than 1 question mark colon, use if-else instead. Clear code beats clever code. A sentinel value is a special value that signals stop. It is not real data, just a marker that means there is no more input. Here the loop reads integers, and when the user enters -1, the break stops the loop. The sentinel -1 works because the program expects non-negative data. Choose a sentinel that cannot appear in valid data. Use -1 for non-negative data, 0 for non-zero data, or EOF when any number could be valid. Let's recap. The scanf function reads input from the user, and it returns the number of items successfully read. Always check that value. When scanf fails on non-numeric input, the bad data stays in the buffer. Clear it with a getChar loop that stops at new line or end of input before retrying, or the loop runs forever. The do-while loop is the natural shape for validation. Prompt, read, check, and repeat if invalid. The ternary operator, condition question mark value if true colon value if false, is a compact conditional expression. Use it for simple two-way choices and avoid nesting. For anything harder, reach for if-else. And simple values signal the end of input, like -1, 0, or EOF. Next, you now have all the tools for straight line, branching, and looping programs. But everything lives inside main. In Chapter 4, Functions, you will learn to organize code into reusable blocks that take parameters and return values.